Good afternoon, everyone. Today I will be presenting about earth leakage circuit breakers or ELCBs and molded case circuit breakers or MCCBs. These days, these devices plays a crucial role in electrical safety by preventing the electrical shocks and fires caused by the leakage of currents. First, we will start with ELCBs. The ELCB, earth leakage circuit breaker, is a safety device that is designed to prevent leakage of currents in electrical circuit. If leakage is detected, it automatically shuts down the power to prevent shocks and fires. Commonly used in homes, industries, and commercial buildings for added electrical safety. There are two types of ELCBs, the voltage ELCB and the current ELCB. The voltage ELCB detects the voltage difference between the earth and the electrical system. It is not This type of ELCB is now outdated and not commonly used. The other type of ELCB is the current ELCB, or you can name it also as RCCB. It is a kind of ELCB which detects the leakage of current in the electrical circuit and does not require any separate earthing connection. This is the most commonly used ELCB in today. The working principle of ELCB. ELCB work by continuously monitoring the electrical current. Normally, the current in the live and neutral wires is equal. If the leakage occurs, such as when a person touches the facility wire, there is an imbalance. The ELCB detects the this and trips the circuit, cutting off power and preventing harm. The advantages of using an ELCB is they prevent electrical shock, reduce fatal accidents. They help prevent fires caused by the faculty wiring. They protect electrical appliances from damage. They are easy to reset and maintain. The disadvantages of ELCB are there are many. They may trip unnecessarily due to minor leakage. They do not protect against overloads or short circuits. For that, we need MCB or a MCCB. They require proper earthing to function. The another disadvantage is they require proper earthing to function correctly. Moisture and dust can affect its performance. As we discussed the applications, these ELCBs are mostly used in homes and apartments to protect residents, industries where workers handle high powered machines, and hospitals, schools, offices to prevent electrical accidents. In summary, ELCB plays a crucial role in preventing electrical shocks and fires by preventing leakage currents. Modern electrical systems now use RCCBs or a current ELCB instead of voltage ELCB for a better efficiency. A proper combination of RCCBs or MCBs ensures electrical safety. Now let's move to MCCB, the type. Now let's talk about another important topic, that is molded case circuit breaker, or commonly known as MCCB. These are used in industrial and commercial settings to protect against overcut and short circuits and earth faults. MCCBs are the circuit breakers that can handle high currents up to 2500 amperes. They are used in electrical panels to protect heavy machinery, distribution boards, and power systems. MCCBs works by using thermal magnetic tip mechanism. Thermal trip protects against overloads when excess current flows for a prolonged period, and a bimetallic strip bends and trips the current. Magnetic trip. Magnetic protects against the short circuits. Sudden high currents activates a solenoid which trips the breaker instantly. Looking for the types of MCCBs, standard MCCB which is used in general power distribution, and second one is current limiting MCCB, reduces the impact of short circuits. Adjustable MCCB allows user to modify specified trip settings and flexibility. Motor protection MCCB designed especially for motor circuits. Now let's move on to the advantages of using an MCCB. MCCB protects against overloads, short circuits, and earthfalls. They handle high range currents compared to MCCB or an ELCB. Adjustable trip settings. We can adjust trip settings as we need, or we can customize them. They are highly durable and reliable in industries. Now let's talk about the cons or disadvantages of MCCB. MCCBs are more expensive than MCBs. These MCCBs are more larger in size and require more space to occupy. And these MCCBs must be manually reset after tripping. As we know, MCCBs are used more in industrial power distribution to handle high loads and heavy machinery protection for in factories, commercial buildings and hospitals will use these MCCBs, and electrical substations also use these MCCBs for circuit breakers. And MCCBs provide superior protection for industrial and commercial electrical systems. They prevent damage from overloads and short circuits, while offering adjustable settings for a flexibility and proper selection ensures safe and efficient power distribution. This and that concludes my presentation on ELCBs and MCCBs. I hope you now have a clear understanding how these devices ensures electrical safety. If you have any questions, I would be happy to answer them. Thank you.